Welcome back, students. The next problem is obtain a DFA to accept odd number of A's, even number of A's. So there are two problems. What are the odd number of A's? So it could be 1A, 3A, so on. So odd number of A's. 1A, 3 A's, 1, 2, 3, 4, 5. 5 A's, they should be accepted. So what is the design? This is state Q0. This is the final state. 1A should be accepted. Now 3 A's. So 1, this is one more A. Come back. Okay. So let me take sigma equals A itself, only A. So let me take a simplest design. Odd number of A's. 1A, final state. 2, 3, final state. 4, 5, final state. Like this. Okay. 6, 7. So yeah, these are the transitions. So M equals Q sigma delta Q0 F, where Q is Q0 Q1, sigma is only A, Q0 is the start state, Q0 is the start state, final state Q1, Q1 is the final state. So what about delta, the transition function? We have only A is the input. There are two states, Q0, Q1. Q0 is the start state, Q1 is the final state. So this would be the table. Q0 on A goes to Q1, Q1 on A goes to Q0. So this is the simplest diagram I can say, because there is only one input. This is delta. Okay. So this is to accept odd number of A's when sigma equals A. What if we have two inputs? Sigma equals A comma B. So let me modify here itself. Sigma equals A comma B. So if sigma equals A comma B, this is I have to accept odd number of A's. So any number of B's, I remain here. Any number of B's here also, that doesn't matter. It is a don't care. So we can have any number of B's in the start state. We can have any number of B's in the final state. What matters for us is the count of A's. So sigma equals A comma B. Sigma equals A comma B. And the transition function changes. The transition function would be, now we have Q0, which is the start state, then Q1, which is the final state. This is on A, this is on B. This is sigma, this is Q, which is delta. Q0 on A is Q1. Q0 on B would be Q0 itself. Q1 on A is Q0. Q1 on B is Q1. So this is the DFA to accept odd number of A's. So we have done two designs with sigma equal to A. Other one is sigma equal to A comma B. So let's see how to design the DFA to accept even numbers. So if we say even numbers, epsilon is also included. To accept even A's. So 2 A's accepted, 4 A's accepted, 6 A's it should be accepted. In between we can have any number of B's. So this is okay. We can have any number of B's, that should be accepted. What matters for us is the count of A's. So the design goes like this. This is empty string also should be accepted. So Q0 itself is the final state. We get 1A, it should be, yeah. So 1, 2, 3, 4, 5, 6, 7, 8. So what we can say is we are accepting even number of A's. And what happens to B's? We can have any number of B's. That is okay. So M equals Q sigma delta Q0 F, where Q equal to Q0 Q1 sigma equals A comma B. Q0 is the start state. Q1 is the final, Q0 itself is the final state. Q0 is the final state. So the transition table goes like this. Now Q0 on A is Q1, Q0 on B is Q0, Q1 on A is Q0, Q1 on B is Q1. So this is the transition table. This is TT, transition table. So this is to accept, the DFA to accept even number of A's. Thank you.